There are a few different definitions for acids and bases, and one of them is Bronsted-Lowry definition. In this definition, acids donate a proton and bases accept a proton. Let's check reaction between HCl and H2O. As you can see in this reaction, HCl is losing a proton or donating a proton and becomes a chloride ion. So HCl is the acid in this reaction. After losing the proton, HCl becomes chloride ion, and chloride ion is conjugate base of HCl. Okay, what happens to H2O? As we can see, H2O accepts a proton, gains a proton, and becomes H3O plus, that we call it hydronium ion. So H2O in this reaction, since it's accepting a proton, is a base, and hydronium ion is its conjugate acid. Okay, let's check another reaction. In this reaction, tertiary butoxide gains a proton and becomes tertiary butanol. Okay, so tertiary butoxide is gaining a proton and becomes tertiary butanol. So tertiary butoxide is a base in this reaction. And tertiary butanol is conjugate acid of tertiary butoxide. Now in this reaction, H2O is losing a proton or donating a proton, and it becomes hydroxide. So H2O is acid in this reaction, and hydroxide is conjugate base of H2O. When a base accepts a proton, the resulting compound is called conjugate acid. For example, in this reaction, when tertiary butoxide accepts the proton, it becomes tertiary butanol. So tertiary butoxide is base because it is accepting a proton, and the resulting compound after accepting the proton is tertiary butanol. So tertiary butanol is conjugate acid of tertiary butoxide. When an acid loses a proton, the resulting compound is called conjugate base. In this reaction, H2O is losing protons. So H2O is acid in this reaction. And after losing proton, H2O becomes hydroxide. So hydroxide is conjugate base of H2O in this reaction. Identify acid, base, conjugate acid, and conjugate base in the following reaction. Here we have this compound, which is benzoic acid, and as you can see, benzoic acid becomes this compound. It's losing a proton and becomes benzoate. So we know that acids donate proton, they lose proton. So benzoic acid is the acid in this reaction. And when acid loses the proton, the resulting compound is the conjugate base. So this benzoate is the conjugate base of benzoic acid. And then we have hydroxide, that becomes OH, so it's accepting a proton. And we know that bases accept protons. So hydroxide is a base in this reaction. And when a base accepts a proton, it will result in conjugate acid. So this is the conjugate acid of hydroxide. H2O is conjugate acid of hydroxide in this reaction. What is the mechanism of reaction? In acid-base reactions, base will abstract a proton from the acid. So a new bond forms between electron pair of base and proton of the acid, and bond between the proton of the acid and the rest of the acid will break. So as you can see in the product, there is a new bond between base and the proton, and this is the conjugate base of the acid. The bond between hydrogen and oxygen here in this acid, bond between hydrogen and oxygen, this bond will break. This reaction is also an acid-base reaction. Methanol losing a proton and becoming methoxide. So methanol is the acid and methoxide is the conjugate base. And hydroxide is gaining a proton and becoming H2O, water. So hydroxide is the base and H2O is conjugate acid. Now in this reaction, a lone pair of hydroxide, an electron pair of hydroxide will form a new bond with hydrogen of methanol, with proton of the methanol. So a new sigma bond forms between this oxygen and this hydrogen, and this is the new bond here in H2O. This new bond forms. And since hydrogen can only have one bond between hydrogen of methanol and oxygen will break, and both electrons will collapse on oxygen, and product is methoxide. So the first arrow shows a new bond is forming between oxygen of hydroxide and hydrogen of methanol, and the second arrow shows that bond between hydrogen and oxygen of methanol is breaking. For each reaction, draw the mechanism and identify the acid, base, conjugate acid, and conjugate base. In the first reaction, hydroxide is gaining a proton, so hydroxide is the base. And phenol is losing the proton, so phenol is the acid. Phenoxide is conjugate base of phenol, and H2O is conjugate acid of hydroxide. Now, mechanism of reaction. We know that an electron pair of the base will form a bond with proton of the acid, and bond between proton of the acid and, in this case, oxygen will break. So both electrons will collapse on oxygen of phenol, and phenoxide forms plus H2O, and this is the new bond that forms between oxygen of hydroxide and hydrogen of the phenol. And this is the mechanism of reaction. Okay, for the second reaction, again, lone pair of an electron pair of the base will form a new bond. This arrow means that new bond is forming between lone pair of nitrogen and hydrogen of HCl. And now the bond between hydrogen of acid and chlorine will break, and both electrons will collapse on chlorine. So here you can see the new bond that forms between nitrogen and hydrogen, and chloride forms, which is conjugate base of HCl acid.